Hello, my name is Anuprabha Dandapa, and today I'm going to be presenting my research on seizure prediction with machine learning for treatment of Landau-Kleffner syndrome. I'm a senior at Lexington High School, and I'm also the captain of my school's Artificial Intelligence Club, and this is one of the projects that I conducted. I'm passionate about helping families who suffer from rare diseases, and in order to help the rare disease community, I decided to conduct this research. The agenda of my presentation today is as follows. I'll be discussing the background, methods, related literature, analysis, and recommendations of my research. So getting into a little bit of background here, Landau-Kleffner syndrome is a rare genetic disease that is associated with a mutation in the GRIN2A gene, and it presents with a loss of ability to comprehend and generate speech in children of ages 2 to 8. And this disease is more prevalent in males, about twice as prevalent than it is in females. The disease is diagnosed with an electroencephalogram, or EEG, and due to the deteriorating communication skills of the affected children, they may become injured in a seizure event if they're not in a safe environment. So in order to combat this problem, I decided to create 8 machine learning models, and they can be seen on the right over here. And the 2 seizure stages that I considered in my study are the preictal and ictal stages of a seizure. So right before a seizure occurs, a patient is usually able to feel some signs that a seizure event is impending. And so they might feel fatigue or dizziness or irritability, and this can also be seen on the electroencephalogram. On the left here, we can see the preictal data for 3 EEG channels, and on the right here, we can see the ictal data, which is during the seizure, and you can see the rapid spiking motion that is characteristic of a seizure. So the data set that I used in this study is the CHB-MIT EEG data set. And in this data set, I had data from 23 channels and 24 patients. So for pre-processing, I calculated the feature importance scores for each column, and any columns that had feature importance score of less than 0.03 were removed from the data set. And then on this side, we can see the correlation matrix, and I plotted this correlation matrix to see which columns had high positive and negative correlation, and those columns were removed from the data set. And then also I assessed multicollinearity by calculating the variance inflation factor, and columns that had variance inflation factor of higher than 5 were removed from the data set. And the equation for calculating that is shown here. So these are 6 out of the 8 models that I constructed in this study. The first model that I constructed is the KNN, or K-nearest neighbors model, and in this model, the algorithm tries to find the distance between a given data point that you're trying to classify and the data points that have already been classified, and it uses the Euclidean distance formula, which is shown here, in order to calculate the distance, and based on that, it makes a classification. The next algorithm that I created is the SVM model, or support vector machine model, and this basically separates data and then tries to maximize a margin of separation around the data, and the points that end up on that margin are called support vectors. Next, I created 4 decision tree models, and 2 of them are shown here, the basic decision tree model and the AdaBoost model. And so the decision tree model is basically a flowchart, and this flowchart is created by calculating the Gini impurity of each parameter, and then an optimal flowchart is created by determining which node has the lowest Gini impurity, and that's the root node or the top node, and then Gini impurity increases going down the flowchart. And then AdaBoost model is a variation of the decision tree model, and this model has a lot of small decision trees called stumps, and each stump has a different amount of say, which can be calculated by this equation over here. And based on the amount of say for each stump in the sequence, a classification can be made. And then lastly, I created 2 neural network models, the MLP, or multi-layer perceptron model, and the sequential model. So the MLP model had 3 layers, and the sequential model had 5 layers. Moving on to the related literature, I looked at 3 papers which also use the same CHB-MIT dataset, and they also use similar models such as the KNN and SVM models. And across the 8 models, I found that my models, the KNN and sequential model, had higher accuracy than any of those found in the other studies that I looked at, and they had 94.53% accuracy and 97.76% accuracy respectively. And this table shows the accuracies of my models compared to those of the models in the related literature. In conclusion, I created 8 machine learning models which have not been observed in any other published literature, and I used them to predict the onset of seizures so that it can be used in treatment of Landau-Kleffner syndrome and any other epileptiform disorders in combination with at-home EEG applications. In the future, I hope to explore other types of algorithms or improve upon the current algorithms and increase the accuracy, and also get data from different types of seizures so that the results are more accurate and generalizable. These are my references, and thank you so much for listening.